So let me look in the homework and see if somebody sent me something. I remember seeing something. Math 111. Yeah, there's a couple of questions. Trig. I'm looking for down here. I don't see any. Okay, wait a minute. Okay. Well, that's 155. So that's another, I went over that one. Okay, so these two. I've got two questions. One is from review 4 and the other is from review 6. So these are probably questions that somebody went and did extra and they had questions on. So some of you may not have seen these questions. So let's look at the first one. R4, this is from the review 4 section, 53, number 53, and number 16. If you go to the review 4 section, this will look like number 16. And first of all, is it a test question? It could be, yes. It could be a test question. First thing you want to do is get a common denominator. So I will give you a second to write that down. And I will also pull up the handy dandy do-jigger. And I'm going to make it smaller. Give me a second. And there we go. So this one says 8 over b minus 2 minus 5 over 2 minus b. I'm going to write this differently because I've got a similar denominator here. I believe I can make this work. So what I'm going to do is I'm going to rewrite this and do 8 over b minus 2 minus 5 over negative b plus 2. Well, it looks like to me that I could factor out a -1 on top and bottom right here, and it might give me a common denominator. So 8 over b minus 2 minus -1 over -1, and that leaves me with a -5 over b minus 2. Now, -1 and -1 is going to be a positive, so that's going to make this a positive. So it looks like to me it's going to be 8 plus a -5 over b minus 2, and that should be 3 over b minus 2. So I would go back and we do 3 divided by b minus 2. And I believe the sign's wrong. I believe this is supposed to be 11 because this negative and a negative turns into a positive. I thought it was wrong. 11 over b minus 2. That should be the correct answer. It could be a test question, but I doubt it because it is a review question. I'm trying to get back. It won't let me. Okay, 11 over b minus 2. That should be the answer. Okay, I have no idea what the answer is, so let's see what they get. 13. Okay, 8 plus 5 is not 11, Dork. It's 13. Sorry about that. I can add. I just didn't add on that one. My bad. Can you not see my board? Well, I just took it off. Sorry. Sorry about that. I said 8 plus 5 is equal to 11. I don't know why I said that. So just remember this right here. If you factor out a negative, that's going to make that positive because the negatives right here will make that a positive. and change that to a 13. Okay, so remember, when you got one like this, you can actually rewrite it and multiply by -1 over -1. And -5 times a negative is +5. I had an extra negative right there. That's why I got it wrong. There we go. -5 over b minus 2. And then -5 times that negative is a +13. So that's a 75% homework question, maybe a 25% test question. Okay? Just make sure you don't add 8 plus 5 and get 11. Please don't do that. Next question. This is R6 37/29. So this is another review question. And this could be a test question because it's very, straightforward. So we got to break up everything into square roots. Now, I'm gonna go around the world here to show you how to do this. And remember, I'm not teaching to the people that invented trigonometry. I'm teaching to the people that are trying to catch up because they're rusty. Okay? Just want to make note of that, because I really don't care about the people that wrote the book. I care about the people that don't know how to do it. So, square root of 448, x to the 8th, and y to the 19th. Okay?
We can't see your paper.
I know. I write it down first and then I put it up. Gotcha. I'm sorry. I'm trying to do it so y'all can write it down while I'm writing it down. I try to remember to put it up, but sometimes I do forget. I'm sorry. All right. So the first thing I'm going to do is I'm going to put everything in terms of squares. Now, 448, I have no idea if I can take the square root of 448. So I'm just going to rewrite it as it is. X to the 8th, I can take the square root of that. Y to the 18th, I can take the square root of that. And y to the 1st, that'll be a remainder. Okay? So 448, I don't have any idea. So what I'm going to do is I'm going to use some prime factorization, because I want to see if I can see a perfect square in there anywhere. So I'm going to go over here and use my old rules of elementary math. 448, 2, 3, 5, 7, 11, and sometimes 13. It's even, so I know I can divide it by 2. So 2, that'll be a 2, and a 4. A 2 will be a 1, 1, and a 2. 2 will be a 5 and a 6. 2 will be a 2 and an 8. 2 will be a 1 and a 4. 2 and then a 7 and 7. Okay, it looks like to me we got a perfect cube in there somewhere. We got 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 6. Dang, 64. So that means that I can break up 64, x to the 8th, y to the 18th, and then 7y still goes under the radical. Okay? Now, the reason that some of y'all are looking at this and going, what the heck did he just do? Is because some of your teachers told you to get the idiot box calculator instead of doing this. That's why. Okay? That's why we got people with cash registers that can't make change because they were told to use a calculator instead of doing stuff like this. So anyway, the square root of 64 is 4. I'm sorry, 8. That's cube root of 64 is 4. The square root of x to the 8th is x to the 4th. Y to the 9th. And left with 7y should be your answer. And I guarantee you there's somebody out there that's going, I've never seen that before. Well, you didn't get your money's worth in K through 12. Actually, it should have been taught in K through 6. Question, gripe, complaint. Okay. So with that being said, let's go over to our handy dandy question. And I'm just going to type in a 3. Well, I'm not going to type in all that stuff. At 8, x to the 4th, y to the 9th. Can I move that? Yeah. It's a miracle. That's how you do it. Remember, put everything in terms of what? A cube or square. How do I know that? Well, a square is 2. Okay, remember, your index here is a 2. So that means that you got to break everything into multiples of 2 or a perfect square. Exponent, multiples of 2. A number, perfect square. So that's why I did this over here, so I could find my perfect square, which was 64. All right, so those are 2 questions that were sent in, and that's how I do things. So I haven't got any other questions on the review. So that means what? That pretty much y'all understand the review. So with that being said, we are ready to go into chapter 1. So let's look at your handy dandy handout. And I think we go, not chapter 1, but chapter 9, I think it is, where we start to actually talk about trig. Okay, so Math 111 syllabus. All of you have your handouts out. I mean, your important handout. And that is 9.1 through 9.5. Okay, now, when we're talking about trig, we're talking about the science of triangles. Okay, when you talk about trig, you're talking about the science of triangles. The father of triangles is Fermat and Pythagoras. Okay, those are the 2 that are given. Well, I hit e-text once. There's the designation of father of trigonometry. And basically, we're dealing with the Pythagorean theorem a lot. Everything is based on the Pythagorean theorem. So you're going to see a lot of the Pythagorean theorem. 9.1 goes into what is an angle. And an angle is the intersection of 2 planes. Let me get, if I ever get there, 9.1, angles, arcs, and their measure. And I'm not gonna go over this word for word, but you should, if you've never, okay, let me go ahead and say this. If you've never had trig before, okay, of course I know some of y'all wrote this book, but if I'm talking to the people that's never had trig before, if you've never had trig before, then tonight you need to go home and read whatever I have covered, because you might pick up something here and there that can help you make the transition over from algebra to trig. Those of you that are rusty, follow along with me and you'll probably be okay. Those of you that wrote the book, well, you already know it all, so we're not worried about you. Okay, when we're talking about intersection of 2 lines or 2 planes, this is what's formed. A vertex, and the way that you measure a vertex is with an angle. Now, there's something strange about trig in academia and the real world. Okay, I grew up, my father was an engineer, okay, and I grew up in the world of surveying. And if any of you know anything about surveying, surveying is trigonometry. Okay? Surveying is trigonometry. It's studying horizontal and vertical curves. I mean, horizontal and vertical angles. Sorry. You do also do curves also. I'm going to move this over here for a second. And when you study horizontal and vertical angles, you've got to know how to do things in the triangle world. And that means that you have to measure angles. And when you measure angles, you use what's called a theodolite, or it's called a transit. A transit is the old-timey word, and a theodolite is the new one. I don't know how to spell theodolite, but it's close enough. If those of you don't know what it is, it's a man standing out with a little camera-looking thing on a tripod. Now you don't even need that. Now you do GPS, which now you see a man with a circle and a little computer pad right here, and he's usually got an orange vest on. Okay, that's surveying. And basically what you're doing is you're mapping an area with horizontal and vertical curves. Now, what are horizontal and vertical curves? Well, first of all, I mean, not horizontal and vertical curves, horizontal and vertical angles. First of all, when you turn an angle, a horizontal angle, they say the opposite in academia. In academia, they tell you that turning an angle this way is positive, and turning an angle this way is negative. In the real world, you always turn right angles, and I'm just showing you this. Academia. In the real world, in the real world, you're told to turn right angles. You turn right angles. Okay, so in the real world, if I was to go out and turn an angle in the field, I would go to the right. Now that's one thing that is different from academia. Okay, and I'm just telling you this for your information. Okay, this is not, I'm not going to test you on this. I'll test you on this because we're in academia. All right. Another thing in the real world is the quadrants. Okay, the quadrants are backwards. All right. In academia, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. In the real world, northeast is 1, southeast is 2, southwest is 3, and northwest is 4. So when I am doing some of this stuff, I may actually revert back to this side and by mistake. So if I do, I want you to know that I'm not crazy and that I do know what I'm talking about. But when you grow up in this world, it's kind of hard to do everything this way when it's opposite in the real world. Okay? So what is a horizontal and a vertical angle? A horizontal angle is an angle that you turn horizontally with the center of the earth. Okay, horizontally. So like this is the center of the earth, or this is the earth. And this is the center right here. And you're sitting with a transit right here, and you turn this way with your angle. Okay? So this would be like if let's say this is a house and you're sitting right here looking at the house, and you've got your tripod sitting right here, and you've got a, let's say you've got a point right here that your guy's standing on, and a point right here that your other guy's standing on, and you turn an angle from here to there. This right here is called a horizontal angle. Okay? So you got a house sitting right here. You got a guy sitting right here, right beside the house, and you turn an angle from this side of the house to this side of the house. That is called a horizontal angle. Well, what is a vertical angle? A vertical angle has to deal with elevation. A vertical angle is if you're sitting on the same world, and here's your center, and here's your, and you're turning an angle up. That is a vertical angle. So if you're sitting at the bottom of a hill, and this is your tripod, and there's the property, looks like this, and then it goes up, and then your guy's standing up here with the rod, this right here is a vertical angle. So vertical angles have to deal with elevation and topography. Horizontal angles having to do with construction / layout of highways. Okay? Just giving you some kind of reference to understand what we're doing here. Okay? Okay, can everybody see my screen?
Yes, sir.
Okay, yes. Okay, let me put it to you this way. Is there anybody that cannot see what I'm doing? Because I need to send out the present screen again if I need to. All right? So when you're going into engineering and, well, when you're going into engineering and architecture or whatever, these two are very important. Okay? So your vertical angle, called zenith angle, your horizontal angle is called an angle. That's usually what they call it in the real world. Zenith angle, that's above 90 degrees or below 90 degrees. If you're going downhill, it's more than 90 degrees. If you go uphill, it's less than 90 degrees. If you are talking about a horizontal angle, you're going around 360 degrees. So, how do we measure angles? We measure angles in degrees, minutes, and seconds. Almost like a clock. Okay, there's 360 degrees in one revolution around the circle. There is 60 minutes in a degree. And there's 60 seconds in a minute. Now, when you measure these, because most of you, and I'll tell you right this, most of you only know how to turn a degree with a compass or a protractor. Now, this project that we're going to be doing, you can use string and a protractor or a pin laser. You know, the laser that the cats play with. You put the light on the bottom of the floor and the cats chase it. If you've got one of those, that'll help with this project, okay? I haven't sent you the stuff yet. I'll send it to you sometime before the end of this unit, okay? I'm not going to be very, it's not a big deal to me. But anyway, A compass, you're not going to use that in here because a compass, it's easier to use a protractor and a pen or string. Okay, so we're going to be using protractors in here for that project. Otherwise, that's it. We're not really not going to, we're going to talk more about calculating angles and adding and subtracting angles than we are actually measuring angles. But protractor is what you're going to use. So make sure you pick up a protractor. The larger, the better. Because that project, you're going to be doing some stuff outside, and the larger the protractor, the better. Also, think about getting some string, like some cord, a little bit stronger than kite string. It's got to be stronger, like the cord that you mark out a house with, or the cord that's on a blue snap string, construction string, chalk string, that real thick, not thick, like your, kind of like the width of your pen, a cord bigger than the width of your, I'm sorry, the width of your pencil point or your pen handle, pen point, but a little bite bigger than that. Smaller than clothesline cord, but bigger than kite string. I'm trying to think of a good shoestring type cord. Not flat, but it's round. It's got to be round to be easier. And I'll show you what we're going to do with that project later on. It's not very difficult, but you need to have a pen laser, or string works better because a pen laser you can't see in the daytime. You'd have to do it at night so you can see it better. But anyway, the protractor is what we're going to use, and the protractor only goes to degrees. And that's not good enough for the real world. So that's why we have a transit or a theodolite. And I'm just going to show you a picture right quick of a transit or a theodolite. Now, back in the day before electronics, you had a transit. And a transit looks like, that's not a transit. What the heck? Hold on. It's the name of a van. That's what it is. Surveying transit. There. Okay, these are theodolites. I'm going to show you a transit. There's a transit. Does everybody see that okay? In fact, I've got one exactly like this. Oh my gosh, that's exactly like the one I got. The one I got in my room looks just like this. Got a plate like that. Looks just like this. I was raised on a transit like this. Can everybody see the picture okay? Just somebody say yeah. Okay.
Yeah.
That's a transit. Now, before electronics, this transit would go up until the nearest minute. To the nearest minute. So if I needed to turn an angle of 25 degrees, 32 minutes, I could do 32 minutes. But it would be I would just put it a little bit over 30. Very inaccurate compared to one of these that I have. And that's the theodolite. Okay, theodolites are electronic. This reads up to about 3 seconds. So what's more accurate? The transit or the theodolite? The theodolite. So that means that in the last 30 years, have we gotten more accurate with our measurements? Yes. Okay. Now, it's kind of going backwards because the more accurate is the theodolite. But now, GPS is getting better, and a GPS rod probably won't show it. GPS, yeah, looks like that right there. There's a GPS rod right there with the computer on the side. Nowadays, you just use a GPS rod, and they get down, and you have to pay. A lot of people say, well, my GPS is only good to 8 feet. Yeah, but your GPS costs $30, and this GPS costs about $30,000. Okay, this GPS will get down to within a ½ inch. Okay, is everybody with me? So as you can see, you know, there's three things that you can measure angles with: a transit, a protractor, and this doesn't really measure the angle. What it does, it uses the satellites to do the math for it. Okay, so the satellite's doing the math, not the actual surveyor. So with that being said, we're going to be using the protractor when we do our project, and a string like a cord, and you're going to go out and pick a couple of things, and you're going to measure the angle, and you're going to be able to tell by trigonometry how high the fire hydrant is, or what the length of the stop sign is, or whatever you end up measuring. You're going to do a horizontal angle, and you're going to do a vertical angle. And this is horizontal angles. Degree measure, 1 degree, okay, make sure you write down acute and obtuse. Y'all know that from geometry. I hate definitions. Your straight angle is 180 degrees. That's 180 degrees. Your acute angle is less than 90 degrees. Obtuse angle is more than 90 degrees. And you can also have a 90-degree angle, which is straight like that. And 90 degrees is called complementary. And 180 degrees is called supplementary. Now, a lot of this is in your book, and a lot of you that's had trig before, you know what I'm talking about. But for the ones that's never had trig before, you need to be reading this. Okay? Next page. And there's your angles, and here's your supplementary and complementary. This is complementary. This is supplementary. Okay. Make sure you can do a problem like this. This is example 1. I don't know how good y'all are at complementary and supplementary angles, so we will go ahead and do an example of both. This is on page 613. And this is a test question. So the first thing you do is discern which one you're doing. Well, if I give you an angle like this, you know that it's going to be a right angle. So that means complementary. And I tell you that this is X degrees. And I tell you that this is X plus 30 degrees. Then I know I can actually take X plus 30, and that's going to equal 90. Now the 90 comes from the two lines coming together to form a 90-degree angle. And there usually will be a box down here. It looks like this, to show you that those two lines are equal to 90 degrees. And that's where the 90 comes from. So now I do algebra. Just do my regular algebra. And X, distribute that 1, which doesn't change anything. And that gives me X plus 30. 2X plus 30 is equal to 90. Subtract 30. 2X is equal to 60. X is equal to 30. So therefore, this angle is equal to 30 degrees, And this angle is equal to x sub 2 is equal to 60 degrees. Or you could have said, okay, well, that's 30 and this is 90, then this has to be 60. You could use subtraction or you can use back substitution. Now, the problem with this is not the math. The problem with this is what happens when I change 30 to 29 degrees, 5 minutes, and 32 seconds. That's when it hits the fan, because you're not used to doing that. We're going to get to that in just a minute. I'm just going over an overview for some of you that never had trig or sucked at trig. I'm showing you the basics. Okay? So supplementary would be 180 degrees. And you've got an angle here that is 3x, and you've got an angle here that is 5x. Well, since you've got this arrow doing this, that's just like the box telling you 90. This arrow tells you equal to 180. Or the directions will say supplementary or complementary. So now I just take 5x or 3x plus 5x is equal to 180. 8x is equal to 180. X is equal to, well, 8 will go into 18 2 times. That leaves 20. 8 will go into 20 3 times, or 2 times. That'll leave 40. I guess, somebody check me. Divide 180 by 8, please. And that should be 22.5 degrees. Somebody check me with a calculator, please.
That's right.
Okay, now, you know that that degree is 22.5, but that's not your answer. You've got to take that x and plug it in here. So 3 times 22.5 is going to be 67.5, or I think it's 67.5. Somebody check me.
That's right.
And then 5 times 22.5. 5 times 20 is 100 and is 100. I'm going to say 121.5. Add them together and see if you get 180. 8, 7, 8. I think I'm off one.
112.5.
112.5. Thank you. 112.5. And that's how you do complementary and supplementary angles. Now, again, that I'm usually not going to have a problem as long as I keep these angles good whole numbers for you. But when I change them to minutes and seconds, that's when things change. So let's go over and look at, and there's an example right there. And here we go, going into conversions. Okay. I want to go over minutes. Okay, here we go. Degrees, minutes, and seconds, and I showed you how to do it. Okay, here's 2 calculations right here. And these are test questions. So far, I've covered 2 test questions. These are the first 2 test questions right there that you will see on from 1.9.1. Okay, here's other test questions right here. That's these guys right there. Perform the calculation. 51 degrees, 29 minutes, 0 seconds, plus 32 degrees, 46 minutes, and 0 seconds. Now, a lot of you are saying, well, why is he writing 0 seconds? Well, it kind of helps you, especially right here, to write minutes and seconds because you can't take 12 away from blank. So you got to change this one. B is going to be, and I'm writing this down, I'm going to show it to you in a second. 89, 59, 60 minus 73, 12, 0, 0. So these are the two questions that they got right there, and that's the way I wrote them. Now you could write this one 89, 60 minus 73, 12. Either way. Now somebody tell me what I just did with the one on the right. This is A and this is B. What did I do with the one on the right? Because the book says 90 degrees. Okay, silence tells me that you don't know. Anybody want to take a stab at it?
You took the 60 seconds and made it into a minute?
Yeah.
I borrowed, yes. Now, did y'all learn this concept a long time ago? Yes. Y'all remember when you took, when you subtracted and you were subtracting two numbers and you had to borrow one from the other number? Well, you're doing it here because you can't take 12 away from 0. And 0 was when it was 90 degrees, 0 minutes. You can't take 12 away from 0. So you have to change it into a minute. And you can either do it this way or you can do it this way. Okay. Here, there's an extra step at the end. You're going to have 60 seconds, which equals a minute, which bumps this one up. Or you can just cut the seconds out and just write it as minutes. So let's go with this one. 0, 0. 9 plus 6 is 15. Bring you 1, 4, 5, 6, 7. 1, 3, 8. Are we done? No, because we don't have 75 minutes. How many minutes are in a degree? 60. So that's going to be 83 degrees, 60 minutes plus 15 minutes, 0 seconds. And that 60 degrees becomes of 60 minutes becomes a degree. So that's going to bump this one up to 84. So your answer is 84 degrees, 15 minutes, 0 seconds, oops, or 84 degrees, 15 minutes. And over here, where we borrowed, I borrowed a degree and a minute and a second. So that's why I got 60 seconds, which bumps that up to 60 minutes, which is what you've got. So you can do it here or here. It doesn't matter. You're going to get the same answer. So 60 minus 12 is 48. And 9 minus 3 is 6. And 8 minus 7 is 2. Now you better make sure you know how to do these problems because I will put these on the test.
Isn't 8 minus 7 1?
It probably is, but I can't add. Where do you get 8 minus 7? Yep, 8 minus 7 is 1. Last time I checked. I suck. Thank you, sir. Who was that?
Justin,
Thank you, Mr. Johnson.
you're welcome.
All right. So that's how you do those. So now you got 2 questions about complementary and supplementary angles. And you got 2 questions on how to add and subtract angles. Now, of course, I expect questions. So hopefully y'all will send questions when you're doing the homework, and we will do more. Okay? And you can use your calculator. I'm not going to make a big deal out of the calculator yet because you need to understand the concept behind doing it by hand. So I'm not going to talk about the calculator yet. Okay? Now, converting between decimal degrees and degrees, minutes, and seconds. And I can tell you right now, if you were to walk up to an engineer or a surveyor or an architect or a construction person, layman construction person, and you walked up to that person and you said, I need a steak, not steak that you eat. A steak is a construction piece of wood, drive down on the ground. I need a steak at 22.3 degrees from the building. You tell a surveyor that, he's going to look at you like you're crazy. Okay? Decimal degrees, and I'm going to tell you this, and you can prove me wrong. Decimal degrees is only in academia. You will not walk up to a construction manager and say, we need to turn a 22.3 degree angle. You don't do decimal degrees in the real world. Okay? So I'm going to go ahead and tell you that decimal degrees do not work in the real world. Now, the reason I'm telling you that is because I want you to realize that when you do get out in the real world, engineer, architect, whatever, construction manager, surveyor, nobody's going to walk up to you and say, well, we need to turn 27.6 degrees to set a stake over there for that highway. No, that ain't happening. Okay? When you're in the real world, you use degrees, minutes, and seconds. Okay? Degrees, minutes, and seconds. So how do you change between the two? Well, we're going to talk about that right now. And it's real easy to follow. And I have to look at it myself because very rarely do I run into anybody with decimal degrees. Very rarely. Usually it's, in academia, and that's why I don't run into it very often. Okay, so here it is. You got degrees, minutes, and seconds right here. It says turn to decimal degrees. What do? Well, you put the 14 over 3,600 and then 8 over 60. That's it. That's all you do. So, and then you add those two together and put a decimal here, and that's it. I'm not going to write that down for you because I think you can pretty much, I'll make it bigger for you. I mean, I'm not going to insult your intelligence by saying you can't do it, but I don't think I need to write that down because it's pretty self-explanatory. How many minutes are in a degree? 60. How many seconds are in a degree? 3,600. So you're changing everything to degrees, minutes, and seconds. And that's how you get 74.137 degrees. Like I said, nobody's going to walk out and say, we need to turn 74.137 degrees to the west. No, that ain't happening. You're going to turn 74 degrees, 8 minutes, 14 seconds. Now your compass cannot turn the 14 seconds. Your compass cannot turn the 8 minutes. So you would just turn 74 degrees with a compass. You would turn 74 degrees with a protractor. Capiche? Now here's how you change the one. This is the one you use the most because you got to convert 34.817 degrees to minutes and seconds. And this is how you do it. You set the 34 off to the side. Then you multiply the 0.817 times 60. Then you shave that off, and then whatever's left, you multiply by 60. And that's it. So here we go. We shave off the 34, put that over to the side. Okay. Then we take the 817 and multiply that by 60 and round it to 2 decimal places. And now we've got 34.49. Now we take the 0.02, the remainder of that, and multiply that by 60, and we get 1 minute. Sorry, 1 second. Does anybody do this in the real world? No. They would turn 34 degrees, 49 minutes, and they will try to get close to 1 second, but a 3-second transit is not, or theodolite is still not going to measure down to a second. It's not going to do it. So when you turn 34 degrees in the real world, you might turn like right there. That's 34 degrees. 34 degrees, what was that? 34 degrees, 49 minutes. 34 degrees, 49 minutes is close to 35 degrees. So 34.39 would be right there. And then, of course, the last one I'm not going to even put because you're talking about a millimeter of a degree with 1.2 seconds. That's like a millimeter of a degree. So 34.49, whatever it was. It's close to 35 degrees. So that's 2 more test questions right there. Let me ask a question, and I'm not trying to embarrass anybody, so I'm going to ask who has had trig before. I mean in pre-cal or you had a trig course, okay? In the last year, if you've had a trig course or a pre-cal course, let me see your hands. And leave them up so I can see, because it takes a while for everybody to kind of throw their hands up. Okay, still about half the class. I'm looking, yeah. Well, a little bit more than half the class has had. Okay, you can put your hands down now. We still got about 8 or 10 that hasn't had trig before, so I'm trying to help y'all out. You're welcome. All right, so that's how you change a decimal to a degree and a degree to a decimal. And like you said, like I said, we'll probably be going over some more later. Okay. And let me look at the time because I don't want y'all to go into convulsions. Okay, we might as well go ahead and wrap it up now. Let me go ahead and look at the next page. And quadrilateral, okay, that's not a big deal. That's how many times you wrap around 360. I'll show you that. That's not a big deal. Yeah, let's stop there. I don't want to go into radians right now. So right now, what should you be working on for homework? Well, I don't know why I have to explain this, but I'm going to explain it again. Right now, I'm going to write this down because I looked through the homework, and there's about 25% of you that hasn't done anything, and I'm trying to figure out why you haven't. But for those that are doing what they're supposed to, you should have the review done, and you should have by Monday, you should have 9.1 done, except for questions that you send in to me. Okay, so with that being said, you know, some of y'all have 2 sections of homework to do this weekend. Now, I will take review questions Tuesday, but I'm not going to do that every single. As far as I'm concerned, we're done with the review because I didn't get any questions but 1 or 2 today. And to me, we've had a week going over the review. So the review to me is toast. But like I said, half of y'all hadn't even done that. But I will give you Tuesday. After Tuesday, I'm not going to answer any review questions unless you see me outside of class. Okay? So right now, Tuesday, except for questions. In other words, you'll send me questions. You should have review and 9.1 almost done. Okay? Because I haven't finished 9.1. And that means I would not do any questions on total, that's where you go round and round, and radians. You don't have to do either one of those right now because we'll cover that Tuesday. But to give you an example of what you should be doing, I'm 3/4 of the way through 9.1. So you should be doing 3/4 of the homework through 9.1. And that is the 6 questions I showed y'all, meaning, what are the 6 questions? I showed you supplemental, complementary. I showed you adding and subtracting degrees, minutes, and seconds. And I showed you how to convert. 2 questions of each. So you should be doing that part of the homework up to that point. When it starts asking for the total, meaning that they give you 1,060 degrees, stop. And just stop because we haven't covered that yet. All right, let me look at the roll. And everybody should be present except for the ones that, and remember, tomorrow is it. If you haven't been in your classes for 2 weeks, I don't know who would do that, but if you haven't been in your classes at all for 2 weeks and they're taking attendance, the system will drop you for not attending. Now in here, nobody has to worry about it, I don't think, because I take attendance every Tuesday and Thursday, and you only have to have 1 attendance for the week. So you're okay if you've attended. And you know you've attended because you've attended. So don't start running around like SpongeBob and Patrick. Start freaking out about being dropped if you've been here. Don't worry about it. Some of y'all just like to spaz out. All right. So here is the Math 111. I need to turn off the presentation, and I need to turn off the recorder. Recorder, turn off.